Alright, kiddos. Now today we are going to talk about finding slope from a table. First we've talked about what it was. This is what slope is. It's the change in y over change in x. It's what it looks like. Then we talked about yesterday slope from a graph, and we talked about how to find the rise over the run. Now we're going to talk about how to find the slope from a table. The thing that you are going to have to remember to find the slope from a table is you are going to have to remember that you need to find the change in the y values and put it over the change in the x values, which is all rise over run is. That's not how we say it when we look at a graph. Another way to see this is it might be written like this. It might be written as delta y over delta x. That's just fancy math way to say change in y over change in x without having to write out all those words. But the thing you're going to want to remember today is to find the change in the y values and put it over the change in the x values and then simplify it. So number one, an electronics company has several factories to make stereos. Each factory produces the stereos at a steady pace throughout the day. Over a period of 8 hours, Factory A produces 400 stereos. The first thing it wants us to do is complete the table. Well, the very first thing we're going to have to know is how many stereos do they make per hour. Well, I know that they make 400 in 8 hours, so to figure out how many per hour, I'm going to do 400 divided by 8. Which comes out to 50. So they make 50 stereos per hour. That means in hour number one, they made 50. Then they made 50 more, so that's 100. Then 50 more, and 50 more. And you can finish out your table. And then the next one, Factory B, over a period of 6 hours, produces 360 stereos. Same thing, I've got to figure out how many stereos they make in 1 hour. So 360 divided by 6 is 60. So in hour one there was 60, then there was 120, then there was 180, 240, 300, and then we get to go over here and we get to keep going. This would be 420, and this would be 480. So that's how many they would make. That's your table. So part C asks how many stereos each factory produces per hour. Well, we used that information to fill in our table. Factory A is 50 per hour, and B is 60 per hour. So now we're going to graph a function for each of the factories on the coordinate plane. So we're going to graph what we know. So we're going to just take these points and plot them and graph them. We're going to do them in two different colors. We'll do Factory A in purple, and we'll do Factory B in red so we can see the difference. So Factory A, we're going to, and so Factory A at time 0 had made 0 stereos. Same with Factory B, time 0, 0 stereos. That's going to be important. So they both start right here at 0, 0. But then the first factory, after 1, they had made 50. 2 was 100. Then 150, 200, 250, 300, 350, and 400. So that gets us all the way to 8 hours. And so we're going to connect those with a line. So here is Factory A. Factory B, we're going to plot their points. And this one's going to be a little harder because this goes on a scale of 50. So we're going to have to sort of estimate, but it's okay. So they both start here. But then Factory B, after 1 hour, has made 60. And then after 2 hours, have made 120. And then after 3 hours, it was 180. And then 240. And then 300. So this one's right on. And then it was at 360. And then it was at 420. And then it was at 480. And so this is what the other graph looks like. So we will connect those with a line as well. So here is Company B. And I'll label them so that we can see. This is Company B. And this is Company A. And so we've graphed them. Now from the table and graph, we're going to find the domain and range. Well, if I connect them, then it's going to be a continuous graph, and I find my domain that way. And we're going to assume that it is, because they do not go from 1 hour to 2 hours. Somewhere in there, the people at Factory A worked an hour and a half, and they made 65 radios. And so we were going to have to, it's got to be continuous data. Even though in the table it doesn't appear to be, it can't be discrete data because we cannot teleport from 1 hour to 2 hour. You have to work, an hour and 45 minutes at some point. So the domain for A we'll do it in purple, is going to go from 0 to 8 because they worked from 0 to 8 hours and that's where it stopped. The range is going to go from 0 to 400 because that's how many radios they made in 8 hours. Now factory B, their domain is exactly the same. It goes from 0 to 8 as well because they also worked 8 hours at factory B. But the range is different because factory B makes more radios per hour, so their maximum is 480 and not 400. So there's our domain and our range. So now, if I were going to graph a graph for factory C, and they make 75 stereos per hour, how would that compare to the other two factories' graphs? Well, A makes 50 stereos per hour. B is 60 stereos per hour. So C, which is 75 stereos per hour, I'm going to guess is going to be steeper. So factory C's graph would be steeper than factory A or B's graph because they would produce more stereos over the length of time than either of the other places. So now slope, and we already talked about this, is going to be the change in the y values over the change in the x values. And as mathematicians sometimes we don't want to write out all those words, so we use this Greek symbol delta, which just means change. So the change in y over the change in x, which by the way is a symbol you'll also see in science. That will get used in chemistry and in physics. It will happen a lot. So that delta will not be something you never see again. It just simply means the change in. So we're going to use that information to figure out the slope from some tables. So here is table number 1. I've got, or it's number 2 on your thing, but table number 1, I have my x values and I have my y values. I'm going to find my change in each. So I want to do change in y over change in x. So let's do the y values first. My y values from here to here change by adding 3. They also change by plus 3 here, so they're constant. That's a good thing. My change in y is 3. My change in x happens to be plus 4 because those are increasing by 4. So my slope happens to be 3/4. So the slope from this table is 3/4 or 3 over 4. If I were to graph this, it means my rise would be 3, my run would be 4. So let's try the next one. We're going to do our change in y over our change in x. So right here, my y changes from 10 to 8 is a change of -2 because the numbers are getting smaller. So I'm going to do -2 over. Now my change from -3 to +0, however, happens to be +0 happens to be +3, so it becomes 3. So my slope right here is -2/3. Now I want to show you that even though the next change is not the same, they simplify to the same, so it's okay. My change from here to here, from 8 to 4, is -4 because now I've subtracted 4. So now my y values are changing by 4. But my x values increase by 6, so it becomes -4 over 6. But if I simplify this, it also becomes -2/3, which is the same slope that I had to begin with. So the slope of this line is -2 over 3, no matter which 2 points you pick. Now number 4 is very interesting because if you notice in that table, if you look at the y values, you should notice that the y values are all the same the entire time. That should be a clue to you, but you haven't done this enough that you're going to pick up on it just yet. But if you look, my change from here is 0, and my change here is 0 because nothing is happening. So my change in my y values happens to be 0. My change in my x values from here to here is going to be +3. Which gives me a slope that equals 0. And if you'll remember, horizontal lines have 0 slope, and their equation is always y equals. The reason it's always y equals is because, look, y equals the same thing, no matter what. So this is going to be a horizontal line because it has a 0 slope, and the y values are all the same. So let's do number 5. So number 5, we're going to do change in, oh, there's not room. We're going to do down here. Change in y over change in x. Well, the change in the y values from here to here is +3. So I'm going to add 3. But my change in my x values, look, is going to be 0 because they're all the same. From -2 to -2 is a change of 0. And if you'll remember, I can't turn something into nothing, so this becomes undefined slope. And if you will remember, vertical lines have undefined slope. Their equations are x equals. The reason they're x equals, look, all of my x values are exactly the same. This is going to be a vertical line because it has undefined slope and all my x values are the same. Now number 6 is kind of gross because you have all these ugly decimals, but you know, that's what our calculators are for. So we're going to find our change in y over our change in x, and we're going to use the decimal. So my change from here to here, 0.125 and 0.5, it's getting bigger, so it's a change of 0.375. And I found that by subtracting 0.5 minus 0.125. I just subtracted this one minus this one. I just subtracted them because they're getting bigger. I did big minus small. My x values are changing from 0.5 to 2. Well, if I do 2 minus 0.5, that's going to give me a change of 1.5. And so I have over 1.5. And there's nothing wrong with leaving it that way. This doesn't tell you a whole lot at all. If you wanted to simplify it by doing division, so you did 0.375 divided by 0.15, you would get that it's 0.25, and if you really wanted to be technical, you could say that the slope was 1/4. This is more helpful to you than the 0.25 because if you're going to graph, you want to know the rise is 1, the run is 4. So it helps to go to there, but all three answers mean the same thing. This is absolutely not helpful to you whatsoever. If you leave it like this, it's not wrong, but this doesn't tell you anything. You want to simplify. At least this you can tell is 1/4. You cannot tell that's 1/4. So simplify if possible, always, always. So number 7, it's our last one. On the second day, Paula had 200 pages of her book left to read, while on the 4th day, she had 150 pages left. We're going to complete the table, including the independent and dependent variables, and then we're going to find the slope and tell what it stands for. Well, let's just talk about what we know. We have the number of pages she has left to read and the number of days she's been reading. Okay, so does the pages depend on the days she's been reading, or did the days she's been reading depend on how many pages were left? I think that your independent, your x, is going to be the number of days she's been reading. Your dependent is going to be pages left. Because the longer she reads, the fewer pages she's going to have left to read. So how many pages are left depends on how long she's been reading. And we know that after day 2, she had 200 book pages left. We know on day 4, she had 150. So we've got to figure out our slope, fill in the table, do all of that. So what we're going to do first of all is find our slope. And I know I have gaps. I do not know after day 1 or day 3, but I'm going to be able to fill those in once I know my slope. So to find my slope, change in y over change in x, we're going to go ahead and find that. Our change in y from here to here is minus 50 pages. And that is for a period of 2 days. So our slope is going to be negative 50 over 2, which if we simplify is negative 25 over 1. And if we convert that to what this means by in the situation, y is pages, x is days. And so what this tells me is that she reads 25 pages per day. That's what I know. Every day she reads 25 pages, so every day she has 25 fewer pages left. That's negative because it's about how many pages are left. Well, that means after 1 day, she had 225 pages left to read because I have to be able to do minus 25 from here to make my slope work. And then after 3 days, she had 175 pages left because I need this to also be minus 25 because my slope is minus 25 for 1. What it means is that she reads 25 pages a day. So that is slope from a table. Now you have to do change in y over change in x as opposed to rise over run, although they do mean the exact same thing. You will practice this tomorrow. Have a great day.